Ever just stop and think about how your favorite apps actually work? I mean, how they handle everything you throw at them, from posting a photo to ordering dinner. The magic isn't just in the slick buttons you tap. It's way deeper, down in the architecture, in the big choices made about data. So, let's dive in and uncover the blueprint behind every great application.
It all really comes down to this one single massive question. It's one thing to build an app for you and a few friends. It's a whole different ballgame to build something that can serve millions, maybe even billions of people without just falling over. And the answer? It lies in how they solve a few core problems with data.
Every single successful app, I don't care what it does, has to absolutely master these 4 things. First, storage. You've got to have a place to put a mind-boggling amount of information. Second, speed. You need to read and change that info in the blink of an eye. Third, consistency. You have to guarantee that the data is always accurate. And finally, scalability. It has to grow as you get more popular. You get any one of these wrong, and trust me, you are in for a world of pain.
Okay, so let's tackle the first huge decision every engineer makes. How are we going to deal with this flood of data? This isn't some small detail. Picking your database is one of the most critical system design choices you will ever make. And for decades, the default, go-to answer was the relational database.
A relational database, or RDBMS, is kind of like a set of perfectly organized, interconnected spreadsheets. Everything has its place, and it has to stay there. Data gets stored in these strict tables made of rows and columns, and the structure, what we call a schema, is totally rigid. Think of it like a strict blueprint that the data absolutely must follow. This structure is its greatest superpower. And here you can see that structure in action. Instead of just dumping everything into one giant messy table, we split the data logically. We've got a users table and then a completely separate orders table. The real magic is that user ID column in the orders table. It's like a string tying every single order back to a specific user. This relationship is the absolute heart of a relational database. It's what keeps everything organized and reliable.
So, when is all this rigidity a good thing? Well, it's perfect for any situation where getting the data right is absolutely non-negotiable. Think about your bank account, or an Amazon order, or a company's inventory system. You need to know with 100% certainty that when you move money or sell a product, the data is updated correctly for everyone, instantly. That guarantee is what we call strong consistency. It means the second a transaction is done, everybody looking at that data sees the exact same, up-to-date version. No questions asked.
But as those tables get huge, and I'm talking millions or even billions of rows, a brand new problem pops up: slowness. Asking the database to find one specific user in a sea of millions is like trying to find one sentence in a library with no catalog system. It literally has to look at everything. And this is where we bring in our secret weapon for speed: indexes.
Just look at the insane difference in performance here. Without an index, the database is forced to do what's called a full table scan. It's as bad as it sounds. It reads every single row until it finds what it's looking for. It is brutally slow, but with an index, it can jump directly to the right row. We're talking about the difference between something taking seconds or even minutes and it taking just milliseconds. It's like night and day.
So what is an index, really? Well, the best analogy, and it's a perfect one, is the index at the back of a textbook. Instead of flipping through every single page to find a topic, you just go to the index, find the word, and it tells you the exact page number to turn to. A database index does the exact same thing for your data. It's a short.
And the process, as you can see, is beautifully simple. First, the database gets your request. Maybe find the user with this email address. Instead of scanning that giant user table, it looks at the much smaller, super optimized index for emails. The index immediately points to the exact physical location of that user's row, and the database just grabs it. Boom, done.
But here's the catch, and this is really important. Indexes aren't free. They make reading data way faster, but they actually slow down writing data, because every time you add a new user or update something, the index has to be updated too. They also take up extra storage. So the key takeaway is this: you only want to create indexes on the columns you search for all the time.
For the longest time, the relational model was king. But what if your data doesn't fit neatly into tables? What if your biggest worry isn't strict consistency, but just insane scale and flexibility? Well, this is where a whole new family of databases enters the scene, known by the umbrella term NoSQL.
NoSQL databases basically throw the rulebook out the window. They ditch the rigid schemas of their relational cousins. They're built for the modern web, designed from the ground up to be spread across tons of machines, handle crazy amounts of traffic,
and work with data that's messy, unstructured, or always changing. And NoSQL isn't just one thing. It's a whole family of different databases, each one specialized for a different job. For example, graph databases are all about mapping relationships, which makes them perfect for social networks, where you need to know who's friends with whom. Time series databases are built for data points with a timestamp, great for tracking stock prices or IoT sensor data. And document databases, which we'll look at closer, store data in these flexible JSON-like documents, making them amazing for things like user profiles, which can look different for every user.
So this is what that flexibility looks like in practice. Remember how we had to split Alex's info across 2 tables before? Well, in a document database, you can just store it all together in one neat, self-contained package. And if you want to add a new piece of information later, like a shipping address, you just add it. You don't have to rebuild the entire table structure for everybody. It's that simple.
So now we have these two really powerful but really different ways of thinking: the structured, consistent world of relational databases and the flexible, super scalable world of NoSQL. And this brings us to the ultimate question: which one's better? Well, the answer is neither. That's the wrong question. The real question is, which is the right tool for the job?
This table really nails the core trade-off. With relational, you get that rock-solid consistency and the power to ask really complex questions of your data. The downside? They can be harder to scale out, and that rigid schema can be a pain. With NoSQL, you get incredible scale and flexibility. The trade-off? You often give up some of that strong consistency, and combining data from different places, what we call joins, can be a lot harder.
And you know, in the real world, this isn't an either-or decision. The biggest systems on the planet, we're talking Google, Amazon, you name it, they use a hybrid approach. They use a relational database for the parts that demand absolute perfect consistency, like processing payments, but they use all kinds of NoSQL databases for things that need massive scale and flexibility, like storing user profiles or powering your social media feed.
At the end of the day, the single most important takeaway from all of this is this simple but incredibly powerful principle. Don't be a fanatic for one type of technology. You have to understand the problem you're trying to solve, you have to understand the trade-offs, and then you pick the database that is best suited for that specific task.
And that leaves us with a final question to think about. Imagine you're starting from scratch, building a brand new social media app today. What kind of data problems are you going to face? For user profiles, for the friend network, for the feed itself? Based on everything we've just talked about, what would your first database choice be? And more importantly, why would you choose it?